Welcome back. I've been working on some improvements to the turn-in-place system in our game recently, and I remembered that we don't have turn-in-place yet on our ITER project. I'm sorry, on our, that's the project I've been working on our Let's Make an MMO in UE4 project. And so I'll show you here what we currently have. So you see, it just kind of spins as I move the mouse, which, maybe in some games that's okay. It kind of depends on the game, but I want to have some. You can see if you're running forward, it nicely moves, but I want to have it so that you can kind of move and turn in place. And so that basically what will happen is that as you move a certain amount, then your character will turn to face that direction, right? So you're kind of looking around type of thing. And so we're going to add that today. Okay, so we need to make some modifications to, this is mostly all going to be done in the animation blueprint. So let's go find our animation blueprint. There we go. And pull it from the other screen. And so what we need to do is we need to go to our event graph, and we're going to have to add some more variables here. So we need to know a few more things. We're going to add a variable called root yaw offset, and this is going to tell us, root yaw offset, we're going to change it to a float. This is going to tell us what basically the camera is going to be pointing in a different direction than our character. And it's going to tell us how much, right? So 0 means we're going to be lined up with it, and then it's going to go positive or negative for right and left, and we'll get an idea of how far we are off center. We're going to want to add a new, since we've got a Boolean here, called isMontagePlaying. Okay. And we're going to need a yaw delta. That's a float. We're going to need a distance curve. That's a float. And we're going to need a distance curve last tick, right? So we need to know what it was last tick and what it is current tick. We're going to have a setting here called turn in place. I don't like the name I gave it before. Turn in place threshold. That's going to be in degrees. And then we're going to need yaw and yaw last tick. Okay. That's kind of funny. Saw because they were, yeah, whatever. Okay, so let's see where we're at here. I'm just looking at what we got. We're going to assume that this always succeeds. There's no if statements that stop us from getting here. So we're probably okay doing this at the bottom. So let's do, let's set this one first. So we're going to go, is any montage playing? We're going to say, is montage playing? We're going to need to know this because it's going to change some stuff that we calculate, because if a montage is playing, we don't want to go and run some of the logic. Okay, so that gets us our first one. And then what we got to do is we need to get this yaw value. So what we're going to do, we might already be getting it up here. No, we're not. We're going to pull off here, get actor rotation. And we're going to break this. And we are going to set yaw last tick to the previous value of yaw. And then we're going to set yaw. Right? So basically what's happening here is that this one is one frame ahead of this one. Right? And so we're going to grab that whole thing, we'll move it down just a little bit, and we're going to call this get yaw. Okay, and after we get the yaw, we want to get the yaw delta. Okay, and so to get the yaw delta, what we want to do is we want to say how much did it change in the last frame. So obviously we need some subtraction, and we'll take the last tick minus the current tick. So we're going to hit the minus key, give ourselves a little more room. So now yaw delta tells us how much it changed since the last frame. And we'll call this get yaw delta. And we're just calculating some values here that we're going to be able to use in our anim graph to decide what animations we want to play. And now the important one's coming up here. Let's see, get yaw delta. Nope, we're not there yet. We're getting there. So we got to calculate one more. We got to calculate the yaw offset. So this is this set root offset. And we're going to add a branch here. It decides what we do. Connect that on true. And we're going to pull off an OR. We're going to add an extra one. And we want to check a few things. We want to say, you know, if the montage is playing, don't do this. Or basically just set root yaw offset to 0 rather than the false, which is going to be calculate. And if they're accelerating, if they're walking forward, then we don't need to worry about turn in place because they're moving forward or backward or side to side. They're accelerating. And also, of course, the speed, because they might not be accelerating, but they might be coasting. And so we're going to say if the speed is greater than 0. So basically, false is only going to play when they're not moving or playing a montage. And false is where we're going to do the magic. So what we're going to do for false is we're going to set the root yaw offset. And we're going to set it equal to the previous root yaw offset plus that yaw delta, right? How much did it change since the last frame? So we're accumulating changes. Okay, and we're going to want to normalize this data. Normalize axis. Because this is a rotation value that we're dealing with, even though it's a float, it's a rotation. And that will get us our yaw offset. Yaw offset. Okay. Now what we can do, now that we have that yaw offset, is we can do the magic here. So we're now going to do a turn in place. So we're going to add a branch. Off this. We don't need to do it if the yaw offset is just being set to 0, because otherwise it wouldn't matter. And what this one's going to do is we need to know if we're turning. So we're going to do get curve value. Okay, and we're going to need to do a nearly equal. So we're going to hit equals. It's called nearly equal float. Floats have a tendency to not be exactly 0 because of the way that they work. So is turning. This is going to be a metadata value. This is turning that we're going to add to our turning animations, which we'll look at shortly. On true, we are going to use a sequence. And we're going to do a do once because we want to latch this. And we're going to need a little more room. And we're going to one on false. We're going to reset. Guess maybe in the middle there we can kind of tell. And we've got that distance curve. So we're going to set distance curve to 0. Ooh, not 0. I'm sorry. We're going to set the distance curve. We gotta get another curve value. I'm just going to copy this one. I hit Control-C, Control-V, and this one's called distance curve. The cool thing here is that these distance curves, I had to draw them into all our animations, but they're actually already in the Paragon animations, so that's going to make it a little bit easier for us. We're going to take that value and we're going to multiply it. We wouldn't have to do this, but I wanted to make it a little bit more customizable, so that we can set this turn in place threshold. So we're going to get the turn in place threshold. We're going to assume the default is 90. The reason we're assuming that is because 90 is the value that's being used by the Paragon animations. So we're going to divide that by 90, which will get us a multiplier of 1. So this is just a scaling for that. And we'll use that somewhere else for the threshold as well. So then we're going to take this value and set it to the distance curve. We also need to do distance curve last tick. And it will get set to distance curve, of course. This is a common pattern because you often want to know how things changed. Copying and pasting distance curve right after it, right? Same pattern we used up above. And we'll set that as well here. And of course, the end goal of all this was to modify this root yaw offset. And I'll give it a little more room here. And we'll start calculating it up. So we need the distance curve last tick. We need the distance curve. We need to figure out how much did it change. We're figuring out the delta. And then we're going to multiply this because they're both, the way Epic set these up, they're both negative 90 to 0, whether it's left or right. So that means we need to figure out whether it's left or right and multiply them. Otherwise this won't work. So we're going to pull off this and we're going to create a select float. And we're going to use the root yaw offset itself. And we're going to ask the question, so if it's greater than 0, you're to the right, pointed to the right of the character. If it's less than 0, you're pointed to the left. And so therefore, we're going to multiply the top value by 1 and b by -1. So that just flips it for us based on which way they're pointed, since the distance curve is always negative 90 to 0. We'll see this when we open up the animation. And we'll pull this up here. And we're looking pretty good. So let's grab this. And we'll hit the C key, turn in place. There we go. Okay, so now that we've calculated all of those values, let's go take a look at the animations themselves, because I think that's going to make sense here for this is turning and distance curve. So I'm going to go to our animations, and I'm going to search for turn. And we've got this left 90 and this right 90. So we're going to go to the left 90, and do you see here, you see this distance curve? We can open it up and see it. It goes from negative 90 to 0. And the right-hand turn does the exact same thing. So that's already there. We don't have to add that. But we do need to add a new metadata. So metadata is just true or false. Variables have a float value. So we're going to add a new metadata, create new, which is called is turning. And you can see here it just set, that means it's true. Okay, and we're good there. So now we just need to, now I want to point out one thing here too. This did change. Some people had said they had trouble with this. You know, Epic likes to change stuff all the time and not mention it. The ARPG sample that they have, they actually had to go in and fix these compression settings. So if you are getting some weird issues, you may have to change this. The previous setting was anim compress, bitwise compress only, but it looks like now they've changed it to per track compression. We're going to leave it on this one and see if it gives us trouble. If not, we'll be going and switching it back to the old value, which was this bitwise compress only. Apparently, this can change how this float curve is stored. So at least that's what it appeared based on some of the notes from Epic. There isn't any documentation on it yet. But if you look at the 4.22 upgrade, you'll see a line that says fixed ARPG sample due to animation curves and compression settings. We're going to go open the right 90, and we've already added it, so we can pick it from the list right here, is turning. I got both of those now, so let's go use them. It's going pretty good. So we come back to our animation graph here, and what we want to do is we want to go up to this ground locomotion, and we want to edit this idle. So we're just playing this idle right now, right? But that is not what we want to do. Instead, we want to add, you can nest state machines, which is a really cool technique. And we'll call this turn in place. I'm going to hit Control X to cut that, because I think we want to use it in here. I'm going to purposefully do this wrong, so I can show you what fixes it, because it is an important point to make. Okay. We want to add a state called idle. We'll fix that capitalization. And inside there, I'm hitting Control V to paste this play idle. If you didn't do that step, you can just do play idle. It's right there, that top one. And that should be good for that. But I want to create another state here called turn 90. And this one is going to contain both of our turns. So how do we play two turns? We do blend pose by bool. And how do we know which bool to play? What do you think, guys? How do we know which bool to play? We've already done it before. We take our root yaw offset, because we want to know if it's left or right. And so we take our root yaw offset, and we say, is it greater than 0? Okay. So then we say if it's greater than 0, I actually had that wrong when I said it earlier. It's actually if it's greater than 0, then we want to play, oh no, I was right. It's that you would want to play the turn left one, because that's the direction you are of it. But we're going to do play turn left 90 on true. I'm going to do play turn right 90. This also has 180-degree turns, which are kind of cool, but we're not gonna deal with those today. Okay, so there's a couple errors that you got to be careful of, because these ones always get me. So first, I want to come here, and the condition for ending it, okay, the condition for the turn is just it finishing, okay? So automatic rule-based, this is a new thing they've added. It just means when it's done. Well, here's the problem. By default, they loop, therefore it's never done. So you gotta come in here, you gotta turn these off. I think I also found that I like to play rate of around 1.5. These are numbers you can adjust. You will notice that it's not going to be perfectly smooth. These are numbers you can adjust to get it smoother. So you can play around with the speeds that these animations are played. And all that's good. And we're going to go back here. And we need a condition to start. So for our condition to get into this, we need to do something here. We need to take our root yaw offset. Remember, it can be positive or negative, so we want to do ABS, which is absolute value. So if it's negative 90, it returns 90. If it's positive 90, it returns 90. That's what absolute value does. We want to say, is the absolute value greater than, and this is where we pull in our turn in place threshold. Now, you'll notice that we have not set this value yet, and that is problematic. It will break if we forget to do that. Put 90 in that value as the default. And so now what will happen here is that when it's past 90, which is the amount we're going to turn the camera to make it activate, it goes and plays this turn, and when it finishes, it comes back here. Cool. So there's one other thing that we want to do that I didn't do. I'm just going to come here and save the skeleton. And that was in these turns, and this is the part I don't love. So they're too long, right? This thing is 2.13 seconds. I really don't want that. So these turns are not ideal. If you have better turns, this will work much, much better. We're going to do a bit of a hack and chop these things off. So what we want to try to find out, and you may be able to do this better than I did, but you want to try to find a point where the start is equal to the end, but just past after it gets to 0, right? So we're looking at these values. Okay, it hits 0 right here around frame 29. So we have to go at least to 29. And then we want to I'm holding my fingers up on the screen here on her hand. And we kind of want to find a point after 29 so it slowly returns back. We can't go all the way at the end. We'd really like to put it at the end, but we can't. So you kind of got to go until it moves too much. Until it kind of stops moving. This is longer than it should be, but I think I'm going to go with maybe, so I'm going to right click here and maybe here. Back a little bit. I think I'm going to remove 51 through 65. Okay, and we'll do that in both of them. So we'll take frames 0 through 50. That'll cut this down to 1.6 seconds. It's not going to be perfect, but it'll work for this demonstration. And we can potentially do a little bit of smoothing. To fix it, I'm going to do the same thing here. I'm going to come to about 49, move in this cursor, and we're going to remove frame 1 through frame 64. Okay, let's... Oh. I was going to say let's give it a try. We forgot some very important things. How is Serath gonna move? So we got to come back up here to our locomotion anim graph, and we're missing an important piece here. So what we were doing is this method does not require root animations. However, we are doing root animation. And the way that we do that is by using this nice thing called rotate root cone. And we don't need all these settings, so we're going to come in here and we're going to say we don't need the mesh to component and we don't need the pitch. We really just want the yaw. We'll give ourselves a little bit more room. And what do we use to control this? We use our root yaw offset. Okay, so now that's going to be used, and I think we want to, just in case, we want to double check our settings here. Clear the turn filter, third person character. So the settings that relate to the camera are in our third person character. We've got this yaw, use controller raw rotation. We want that unchecked. Good. And we come to our character movement, and we want, yeah, we don't want orient rotation to movement. We want use controller desired rotation. Right, so we're flipping to this. And we're probably going to slow this down to, say, the default of 360. And it is a number you can play with to match the animation along with the animation rate. So you can kind of balance those two for your game. Okay, let's start it up. There's probably some things we're missing. I know there's something I broke on purpose. Okay, it's still moving as we spin, which is, of course, not what we want. Right, so we are missing something here. Also, I don't like the dark. Come over here and clear that 3600. That'll get rid of the dark. So we're missing an important setting. Let's come back to our animation blueprint. We're doing our root yaw offset, and that all looks good. And we checked our character movement component, which is important for this type of thing. So, and that's good. That's 0. This one unchecked, this one checked in 360. That's good. No issues there. And we come to our mesh. Make sure there's some optimization things here. So one of the things that we're going to want to switch here to get this to work is we're going to want to switch to always tick pose and refresh bones. That's going to make that is going to make our anims run on the server. So potentially that change there is really going to reduce our max number of players due to the fact that the animations are running on the server. But yeah, that's what we're going to do for this method. If we didn't want to do that, we'd probably have to come up with a different way to handle it. Okay, that looks good, looks good. Make sure everything else here is good. Okay. And doing our ground loop. Ground locomotion. And we go into our idle. What was that? Is accelerating. Yeah. That's just because of this here. See if we can actually see what it's doing. It's one of the cool things about this. We can take our root yaw offset. So if we zoom in here, take our root yaw offset up to like 90. See what that's doing, how it's turning the root bone. See? So that's working as it should. Double check this mode. Root motion, that's just what they're coming from. Okay, so we're having a problem. So let me just make sure that's good. That's good. All our turns are set up. These are set up not to loop. Looks good. And so what's happening here, most likely, is that we're not getting our values that keep the offset. So when we set this, so basically the camera spins around right with the controller, and we're basically keep moving the root yaw offset. So as the camera turns 45, the other will go negative 45 the other direction, so that it keeps it off center. And then remember, our distance curves come down here, and it reads that distance curve, and it uses that to then, see here, we're taking the root yaw offset, we're changing it how much it spins, right? So what happens is, as this is turning on the animation plays, it's going to slowly move this back toward 0, right? So that's the way that this works. All these things just get calculated as a way to build up to that, but that's the whole purpose of it here, by getting this actor rotation and adding up how much we're moving. And I think, just check to make sure, did we do have is accelerating. Cool. Just making sure we got that. That's good. So that looks good. So what we want to do is we want to see, what is this root yaw offset being set to? So I did this when I was debugging earlier, and it's a good way to get an idea what's going on as we're turning. Okay? So let's see what's happening here. Because if it's not moving, then we know there's going to be a problem. Yeah, see, it's not really able to build up because the character keeps spinning, right? So we need this number to get up to 90. It's never going to get up to 90 because the character is spinning with us, which is not what we want. We want it to basically have to get up to 90 before it does anything. So we're going to come back here, and we're just going to double check that our turn in place threshold got set to 90. If that did not get set to 90, that would be problematic. But it did, so no issue there. And so at this point, this is it should be accumulating the value and not turning and basically offsetting it over here. What should be happening is that it should be offsetting the root bone. So that it doesn't turn with the character. That's what we're looking for. And we're not getting that. So let's take a look and see if we made a mistake on any of this. So we definitely do the root yaw bone plus this yaw delta, and we're adding them together and adding them to root yaw offset. And we're only doing this if speed is greater than 0, or we're doing it if it's not. So one of these conditions will push it to true, as montage playing is accelerating or speed is greater than 0, but none of those are the case. Or they shouldn't be. And so we look here, yaw last tick minus yaw into yaw delta. Good, no issues there. Make sure we're getting this actor rotation right. Rotation, yaw last tick, yaw, looks good. And we're doing the is montage playing. and that's just a simple grabbing this value from the anim instance and setting it. So I don't see any issue there. So these should be, trying to think of all the magic checkboxes here. Something is slightly different. Distance curve last tick gets set to distance curve. It's not even getting to this point though, right? Because when it's false, right, on the is turning, it's false, it's just going to keep setting this. So what would happen here is that if we went over to our anim graph, it's never going to get to this, because remember, to get to that, it had to have a re-yaw set greater than the turn-in-place threshold, which was 90. You saw there it was just instantly, you know, getting overwritten. So it was not making it to this. So if that's not getting called, that also means none of this is getting called, so the error has to be up higher. So the most likely case is that one of these values here is different. I'll just go through and double check them. So I've got a pawn control rotation on the camera. That's good. That's good. That's exactly what we do. And there's no issues there. And of course, we'll double check the character movement here, but we had already looked at it before. These rotation settings are what have largest effect on how our rotation works, but those exactly match what I've got in my test project. Use control desired rotation is checked, orient rotation to movement. And that runs at the 360. I don't think there's any other thing that's not defaulted there. And of course, our third-person character itself has this use controller rotation yaw, which is what we want. We already checked that before. And the only other place that there would be something would be in the player controller. But I think in this case, I don't think there's anything really of interest here related to rotation. It's all kind of done. It's all kind of done in the character. The player controller doesn't really have to do a whole lot, even though it's what's collecting all of those. Well, let's take one other look. So let's come into our input graph and take a look at what happens there. Oh, we don't have an input graph. Okay, that's fine. We'll scroll up to the top here. So of course we've got our controller yaw input and our controller pitch input. So this is the one that's running on our turn, which is what we're doing here. You compare that, input axis turn. But it's pretty simple. There's really nothing special there. That's just the default. And we don't really do anything. We don't really do anything to modify that. So there's no issue there. There's no settings. We're just adding control yaw input on the pawn. And that's good. So we've got to try to figure out why this root yaw offset is not turning this bone right here. That's the real issue. Component. Because what it should be doing It should be accumulating it and rotating that root bone. So that is the important part. The animations aren't even playing, so there's no issue there. Okay. I thought about stopping the video, but I think we'll troubleshoot this. I think we'll troubleshoot this one here. I think this is going to be a good one. I did this a couple days ago, so I probably have forgotten one of these settings that is important to make this work. But we're going to go through the troubleshooting process. So we know that this value is not what we want it to be. Now that, of course, could happen if this is getting called and returning it back to 0, or if something down here is messing it up. So we could try disconnecting this part, and we could try disconnecting this part. Usually I don't recommend doing two things at the same time, but in this case I'm just looking for something to trigger differently. Okay, you see? There's what we were looking for. And you see they're actually playing. See? It's not turning, but they're playing. This is very interesting. Okay. So we got what we were looking for there. And so let's see, was this the problem? This is probably the problem. But let's double check. Okay. No, that one wasn't the problem. That one was not the problem. Okay, good, good. This is how you troubleshoot stuff. So something bad is happening down here. Divide and conquer, that's how we troubleshoot. And so we've got to ask some questions here. So this error tolerance is interesting. Because we made a huge mistake. Not on our error tolerance, but the value we're checking. So is turning, it's true or false. And we're saying is turning 0. But in reality, we want it to be equal to 1 because 1 is true. And that's what is turning. So this is turning bounces between 1 and 0. We need to ask the question, hey, is it nearly equal to 1? And that is the mistake. As I was copying it over, I missed that value. So, but anyway, we got to do a little troubleshooting and divide and conquer. Let's see where we're at now. There's still some more errors to fix. Okay. Kind of doing something, but not pretty. Not pretty at all. Oof. That's ugly. Okay. Let's so we're kind of getting there, but not exactly what we were going for. So we'll check here to see if we got any errors here. And yeah, we do. We got another error. So what's happening here is that we've got this value here, right? That's how much it changed, and we're just plugging it instantly right into the root yaw offset, but that is not what we want to do. What we really wanted to do is say, hey, what's the existing root yaw offset? And we wanted to subtract. That's why these values are opposite, because we did subtract and not add. We want to subtract how much it changed in one frame. Okay. That's going to help make this look a little bit better. Still not going to be 100% there. Ha! We're backwards. Ha! Okay. Let's see why we're backwards. So he said if root yaw offset is greater than 0, we've got a 1 here and a negative 1 here. We do some multiplication. We do distance curve last tick minus distance curve. We do root yaw offset minus and put it in yaw offset. But we've got them backwards. It's very interesting. Maybe over in the anim graph, if we got those backwards. It's possible. Let's go into our ground locomotion, idle, turn in place. And our idle's fine, but let's go to this turn 90. Yaw offset greater than 0, turn left is in the true, turn right is in the false. That's very interesting. That is what I have, and yet it seems to be playing backwards. It's very interesting. Something else earlier must be backwards. That wouldn't matter. But while I'm here, I'm going to check. Yeah, so I found that there's too much blend time here. I said 0.003. That helped. And then on the blend out, we're actually going to set this to 0.0. You'll see the problem with this later, but we can adjust those. Okay, so it's playing the wrong one. And this isn't the issue here. So what we got to do is we're going to come back to the event graph, try to see why distance curve, like we said, is always negative. Take distance curve last tick. We take the distance curve value, which remember was negative 0 to 0, and we put it into the distance curve. We then take the root yaw offset if it's greater than 0. We select 1 or minus 1 to multiply. Curve last tick minus the curve. Root yaw offset minus whatever that value is, and set the root yaw offset. It looks good to me, but let's come up here. Root yaw offset plus yaw delta. Normalize into the root yaw offset. So maybe our yaw delta's backwards. Yaw last tick minus yaw. Oops. Into the yaw delta, that's not backwards. Get actor rotation Z. Yaw last tick is set to yaw, and yaw is here. It's very odd that is backwards with the same animations. Do we still have animations open? No. Let's go make sure that our animations are moving in the right direction. So remember, it's negative 90 here. That's for turning left. And on the turning right, it's also negative 90. So it doesn't matter the direction that you're going. And that's the reason we have to do this multiply to get this figured out. Let's flip it. See what happens if we do -1 and 1. It's exactly backwards of what I have in my test project, but let's see what happens. Yeah, interesting. It's kind of cool. This is kind of the effect we were going for, but we're not there yet. Watch what can happen. Oh, look at that. That's not what we want. It gets stuck. And so if you were to watch the anim graph, what you would find is that it gets stuck in this turn 90, and you're thinking, how can it get stuck in turn 90 when every time it finishes, it'll automatically go back to idle? How can it get stuck? Well, the problem is it keeps getting re-triggered, right? Because it moves 90 and still stays past 90. And so what we have to do to fix this is there's a cool setting. It's basically flipping too often, and so we really want to latch it. And so what we can do here is there's this max number of transitions that can be taken by this machine simultaneously in a single frame. And this is problematic. And so what we want to do is we want to switch that to 1. And we'll watch what happens here. Should fix the issue. Okay, so what we should be able to do is get it to go far enough that it does 2 of them. See that? You see? I didn't move. I'm just flipping it real quick. You see? And then it does 2. And that's what we want. So we want to flip that to 1. So we should be at a pretty good spot here. I can do small moves like this, or I can whip it all the way around and end up with 2 of them where it plays them in succession. And there we go. We now have a good turn in place. And once we go past that 90-degree threshold. Still confused as to why they were opposite. I feel like that one's probably going to come back and bite us, as something's likely going on. But it seems to be working pretty well. Plays 2 of them like it should. Still jumps when we push forward, but that would take something that this anim set does not have. In our game, what we do is when you're like at 45 here, we actually play a starting animation that turns the legs as it starts. But I was going to add that because it's just a little bit more code to what we added here. But unfortunately, the Paragon doesn't have any animations like that. So, but it's a pretty easy switch. Anyway, now we have turn-in-place animations in our... I think it looks a lot better than just spinning. Now, the one thing we could add here is we could add looking around. So maybe we'll do that in a future one. I think that we have an aim offset. I think it's this one. Oh yeah, we're definitely doing this. Okay, so in a future video, we're going to use the same offset so that as you're moving the cursor, it changes where it looks, and then once she gets her head to 90 degrees, then that's when it starts spinning and flips back the other way. So we're totally doing that, and it's kind of cool. It's got the up down too. It looks really good. We'll add that in a future video. But until then, see ya.